Hello students, today I am going to begin a new topic in class 11 physics, work, power and energy. About these terms you have already studied in the class 10. Means what is work, what is power and what is energy. First of all I will revise these topics and then we will proceed further. So what is work? As you know that work is said to be done when force is acting on the body and body get displaced in the direction of force. This term, this is very important. In the direction of force. Direction of force. So if the force is acting on the body and body is displacing in the direction of force, then work is said to be done. Means, suppose if you have applied the force on the body and there is no displacement in the direction of force, then there will be no work. How will you evaluate that work? So suppose this is a body, here this is the ground and the body is lying over it. You have applied some force F here. On applying force F, it had displaced by distance S in the direction of force. Here it had displaced by this distance. Then what will be the amount of work done? Amount of work done will be equal to the product of force and displacement in the direction of force. That it will be equal to F into S. But suppose if it is like this, force and displacement both are in the different directions. For example, yes, as you know that when a roller is pulled, so force is applied in the slanting direction. Force is acting in the slanting direction, and displacement takes place along the ground. Here, body gets displaced along the ground. Here in this direction of force and direction of displacement both are not same. So what will you do? So we will resolve force in two directions. One in the direction of displacement and other normal to the displacement. As you know that a vector quantity can be resolved into two mutually perpendicular components completely. We can resolve a vector quantity completely into two mutually perpendicular components. What is the meaning of completely here? Means the combined effect of those components will be equal to that vector quantity. For example, here F. This is the force. You have resolved this force along x-axis and along y-axis. So what is the component of force along the x-axis? How will you find that? Already I have told in the vector chapter. Its component along x-axis will be equal to this much. This here, this is fx. And if you take this angle theta, then it will be equal to f cos theta. You know here, cos theta will be equal to base upon height. So it will become f cos theta. Similarly, what will be the component of f along the y-axis? So this angle is theta, therefore this angle will also be equal to theta. What will be the component of force F, vector F along the y-axis? Along y-axis, its component is this. This is the component. This is named as Fy. And what will be its value? You can see here, you apply sin theta will be equal to perpendicular upon hypotenuse. So it will become F sin theta. F sin theta. Now if we apply the parallelogram law of vector addition or triangle law of vector addition, this vector can be transferred here. So here you can see that vector fx plus vector fy will be equal to vector f. Vector fx plus vector fy will be equal to vector F. So in this way, we can resolve any vector into two mutually perpendicular vectors completely. Completely means the combined effect of these two vectors will be equal to this. So here in the same way we have resolved force F along the displacement and perpendicular to the displacement. If we take this angle theta, then what will be its component? What will be the component of F along the displacement? It will be F cos theta. And its component normal to the displacement, will be this. It will be F sin theta. Now see here. Here you have resolved the force into two components. One is the F cos theta, and in the direction of F cos theta, what is the displacement? It is S. So what will be the work done in that direction? F cos theta into S. Then what is the work done in this direction, in the normal direction? Here force is this, but there is no displacement in this direction. There is no displacement in this direction. That is F sin theta into 0. That is equals to 0. So what will be the total work done? Total work done will be equal to F cos theta into S. So simply we write it as F S cos theta. F S cos theta. It's clear. Now see here in which case there will be maximum work will be produced by a force. When a force will produce maximum work, so a force produces maximum work when it displaces the body in the direction of force, because we know that the maximum value of cos theta is 1 and it will be equal to 1 when theta equals to 0 degree. Theta equals to 0 degree. Then cos theta, cos 0 degree equals to 1, and in that case F and S will be in the same direction. So see here, what is the condition of maximum work? Condition of maximum work means under which condition a force is producing maximum work. Under which condition a force is producing maximum work. So maximum work will be produced when theta equals to 0 degree. When theta equals to 0 degree, then the work produced by the given force will be maximum, and it will be equal to what? F S cos 0 degree. Cos 0 degree equals to what? That is F into S. It's clear? Means we can say a force can produce maximum work when it displaces the body in the direction of force. Now then one more thing. Under which condition there will be no work? Zero work. So see here, work will become 0 when theta equals to 90 degree. As we know that cos 90 degree equals to 0. So if the force is acting in a direction normal to the direction of displacement, means force is acting in this direction and displacement takes place in this direction. In that case, theta will become 90 and there will be no work done. W equals to F into S into cos 90 degree. Cos 90 degree equals to 0. That is F into S into 0. That is equals to 0. Means a force will produce no work if it displaces the body normal to the direction of force. There is one more condition of 0 work. Suppose you are applying the force on this wall, you are applying force on this board, and board do not displace. Force is acting, but the body is not displacing. In that case also there will be no work done. It's clear? So there are two conditions of 0 work. One, when the force is displacing the body normal to the direction of force, and second, force is acting but there is no displacement. It's clear. Can you give any example in which there is no work done? So, for example, when you are walking on a level ground, when one walks on the level ground, then there will be no work done. And why there will be no work done? You can see here. In order to walk, what will you do? You will lift your leg. You will lift your leg, and for lifting the leg, you will apply the force in one direction, in this direction. Here, displacement takes place along the ground. Displacement will take place along the ground. So, what will the work done? Work done will become Fs cos 90 degree, that it will become 0. But you have observed that if you walk to some distance, what will happen? You feel tired. So, why it take place? So, it is because of the contraction of muscles when you are walking. When you are walking, then what will happen? Some energy will be dissipated within your body because of the expansion and contraction of muscles. And because of that, our energy level will go down and we will feel tired after walking some distance. It's clear. So, this is the condition. Now, there is one more condition of 0, 1. You have heard about the uniform circular motion. In uniform circular motion, body is moving on a circular path with a constant speed. As you know that uniform circular motion takes place because of under the influence of a centripetal force which acts towards the center of circular path. While the displacement is along the tangential direction. What is the angle? Angle is 90 degree. So what will be the work done? Work done will be equal to Fs cos 90. So here also work done will be equal to 0. Cos 90 degree 0, that is equals to 0. It's clear. Now there is one more. What is the condition of negative work? Condition of negative work. So you can see. Now, negative work. Negative work will be produced by a force if body displaces opposite to the direction of displacement. Body displaces opposite to the direction of force. Which means here you can see body is moving in this direction and force of friction is acting in this direction. Force of friction which is exerted by this ground on the body. It is acting opposite to the direction of motion. So what will be the work done? Work done will be equal to Fs, and what is the angle between these two directions? Both are opposite to each other, so angle will be 180 degree. So it will be cos 180 degree and cos 180 degree. So it will be cos 180 minus 1 means work done will be equal to minus F. There will be the negative one. What is its example? Work done by the force of friction. There is one more example of the negative work. Suppose if a body is thrown vertically upward, then work done by the force of gravity. Body is thrown vertically upward, what will be the displacement? Displacement will be in this direction. Force of gravity F equals to m into g. It is always acting vertically downward. So what will be work done? Both the directions are opposite. Work done will be negative. Work done by the force of gravity will be negative when the body is thrown vertically upward. Is clear? Now, as you know that force and displacement both are the vector quantities. Force is a vector quantity. Displacement is also a vector quantity. But what is work? Work is a scalar quantity. It requires only magnitude to define it completely. There is no need of direction. How can you write this expression in vector notation? Fs cos theta. So we can write it as vector f dot vector work equals to vector f dot vector is this. Now if you have to calculate work done by graphical method, how do you calculate the work? So here suppose there is a graph f versus x graph. Here you can see this is f, and here we have taken displacement in the direction of force. Here x is what? It is the displacement in the direction of force. That you will remember. X is the displacement in direction of force, means force is acting along x-axis. Displacement is also taking place along x-axis. And suppose during whole of the displacement, the magnitude of force remain constant. During whole displacement of the body, magnitude of force remain constant, means work under constant force. How will you calculate that? By graphical method. So f versus x graph, f versus x graph, it will be a straight line. Here it will be a straight line. It's clear because the magnitude of force is constant. If you have to calculate the work done in displacing the body from this position to this position, means what is the amount of displacement here? It will be equal to x2 minus x1. So by your previous knowledge, you can calculate this work as the product of force and displacement, x2 minus x1. Now, what will be this thing here? So if you see here, it will be equal to, this product will be equal to area enclosed by the graph and displacement axis. Graph and displacement axis means area under force versus x curve. X is one displacement in the direction of force, and displacement axis, it gives the work done. Area is equal to work done. Here this area is equal to work done in displacing the body from position x1 to the position x2. Now we will propagate the same idea for the variable force. Variable force means where the force is not constant. Force is not of constant nature. It is varying during the displacement. During the displacement, the magnitude of force is varying. In that case, what will be the work done? So see here, work done here, graph will be like this. Here I have made some arbitrary graph. This is the graph. Here, magnitude of force is varying. Suppose you have to calculate the work done when body gets displaced from position x1 to the position x2. How will you calculate this one? So here also, this area will be the work done. We have propagated the same idea, same concept we have. If you can calculate this area, then this area will be equal to the work done. Now, how will you calculate this area? Because it's one of the side, it's not straight, it is curved. It is not a regular figure. Suppose if it is straight, then it will be in the Lagrangian shape, and then you can calculate the area. But here, one side is curved. Therefore, how will you calculate it? So we will divide this whole area into infinitesimally small, into strips of infinitesimally small width. Into strips of infinitesimally small width. Infinitesimally small width means the width of this strip is dx. This is the width of strip width dx. This. So what will be this area? This is a rectangular strip because it is very small. Therefore, this part will be almost straight, and when this part will be almost straight, it will become rectangular. Which means what will be its area? Its area will be equal to F into dx. We will add areas of all such strips lying from here to here. Areas of all such strips which are lying from here to here. This is another strip. Then there will be the third strip. So in this way we can calculate. So this area we can calculate by using integration. By using integration, what will the work done? Over one strip it will be equal to F into dx. How will you calculate this area? By integrating. Integration is the process of summation of like type of quantities. It is the process of summation of like type of quantity. So what will be work done? It will be integral F into dx. From where to where? From x1 to x2. So this is the formula of work done under variable force. Work done under variable force. Now see here what is the unit of work. About scalar nature of work already I have told. It is a scalar quantity. Do not have any direction. Now what is the SI unit of work? SI unit of work. So first we will see MKS unit and SI unit both are numerically same, both are equal. W equals to F into S. Now assume that F you can write M into A into SH displacement. M is kilogram, area acceleration meter per second square, and displacement it is meter. So here MKS unit is kg meter square per second square. This is the MKS unit of force. It's clear. Now if you see the SI units. So what is the SI unit of force? It is Newton. SI unit of displacement it is meter. So it is Newton meter. And another name has been given to it, Joule. It is Joule. It is clear? Means if F equals to 1 Newton, S equals to 1 meter, then what will the work done? Work done will be equal to 1 Newton into 1 meter. 1 into 1 is 1, Newton meter is Joule. Means work is said to be done, work is said to be 1 Joule when force of 1 Newton displaces the body in the direction of force by 1 meter. It's clear? So all these units are same. 1 Newton meter, 1 kg meter square per second square equals to 1 Joule. Now there is one CGS unit. About that also you know. What is the CGS unit? CGS unit is time and it is R. CGS unit is R. Now you can see here. Newton meter, that Newton here is time. In CGS system, what is the CGS unit of force? It is time. Time centimeter. It is equal to gram centimeter. In place of kg, there will be gram, here centimeter per second square. And it is equal to 1 earth. This means 1 earth equals to 1 time centimeter. 1 earth equals to 1 dyne into 1 centimeter. Means if a force of 1 dyne displaces the body in the direction of foot by 1 centimeter, work is said to be 1 earth. Now after this, I will deduce one relationship between joule and earth. 1 joule, you know, it is 10 to the power 7 earth. Which means already these things you have done in the class 10. So, but for the revision purpose, you can see 1 joule equals to 1 Newton into 1 meter. 1 Newton you can write 10 to the power 5 dyne into 1 meter 10 to the power 2 centimeter. So it is 10 to the power 7 dyne centimeter. Dyne centimeter is earth. It is 10 to the power 7 earth. Now what is the dimensional formula of the work about that also you know? Dimensional formula of work, it is equal to F into S. Force dimensional formula is mLT minus 2 and displacement is L. So it is equal to ml square T minus 2. So this is the dimensional formula of the work. So in this lecture we will do up to here only. In next lecture I will tell you about some new things, means conservative forces and non-conservative forces. Thank you.